Hello everyone, my name is Arindam and I'll be presenting our work Pose-Guided Human Silhouette Extraction under Occlusions. So let us look into why this is an important problem and what is it that we are trying to achieve. So existing methods for human silhouette extraction primarily rely on using pre-trained human segmentation models for extracting the human silhouettes. Now while these methods perform really well, under scenarios of occlusions, these methods lead to fragmented silhouettes primarily because these methods or the models were never trained to handle occlusions. A different way of extracting human silhouettes under occlusions is by estimating the pose key points. Now pose key points are far less sensitive to occlusions, and if we can estimate the pose key points properly, we can, using a pre-trained mapping, we can project the pose key points into the dense human silhouette space. The problem with this method is that because this pose-to-sil mapping is pre-trained on a different dataset, it usually is not able to preserve the human body shape, and it leads to generic human silhouettes conditioned on the pose key points. In order to address these issues, we propose POISE. POISE is a method that preserves the body shape as well as handles occlusions. POISE is a self-supervised framework that integrates the benefits of using a segmentation model as well as using anatomical guidance from the pose key points to extract robust human silhouettes under occlusions. We also show that POISE aids in improving gait recognition under occlusions. So let's look into the underlying framework for POISE. So for POISE, the key idea is to use two noisy silhouettes obtained from two different methods in order to predict robust human silhouettes under occlusions. So the first noisy silhouette is obtained from the pre-trained segmentation model, which is called S, and the corresponding noisy silhouette obtained is called IS. The other noisy silhouette is obtained from the pose estimation model, and which is called IP. Note that these silhouettes offer complementary information. While IS does not handle occlusion, it preserves the body shape. IP handles occlusions, but it does not preserve the body shape. The model under training M is trained to minimize a loss function that agrees with both IS and IP, and in that way M learns to predict silhouettes that handle occlusions as well as predict body shapes. Note that as POISE is a self-supervised method, it does not require ground truth annotations for training. The learning of the model M is solely relied upon by using these two noisy silhouettes IS and IP. Now in order to estimate IP, we first need to train a model P and a model G. So we will now look into how we train the model P and the model G. As we do not have access to the ground truth pose key points on the target dataset, we need to use unsupervised domain adaptation to estimate the pose key points on the target dataset. So this is done by using a mean teacher framework wherein the student model is updated with two losses, the supervised loss on the source dataset and an unsupervised loss on the target dataset. The unsupervised loss ensures that the predictions from the student model and the teacher model are kind of consistent across augmentations. The teacher model is then updated using an exponential moving average weight of the weights of the student model. So now we have a model P which can give us reliable pose estimates on the target dataset. We now use a model G that converts these estimated pose key points into dense human silhouettes. So how is the model G trained? The model G is trained in a way so that it takes the pose key points as an input and learns a mapping between the pose key points and the ground truth silhouettes using a binary cross entropy loss function. Now that we have covered all the details for the framework of POISE, we now move into the experiments and results section. So we start the experiments and results section by introducing how we create occluded images and videos. So this is done by taking random objects from the COCO dataset and pasting them onto the scene. So this allows us to create a dataset wherein we can evaluate our algorithm. We need to do this because there is a dearth of datasets that provide ground truth human silhouettes under occlusions. And it is also noteworthy to mention that it is almost impossible to capture ground truth human silhouettes under occlusions unless there is a multi-view setting or a multi-camera setting. So naturally there is in a single camera setting there would be visual uncertainty, so it would be very difficult to capture the original silhouette behind the occlusion. So so this is how we create occluded images. And moving on, so we present the quantitative results for human silhouette extraction. We primarily evaluate POISE for two tasks: human silhouette extraction under occlusions and gait recognition under occlusions. So in both of these settings, we evaluate POISE against the two baseline methods, IS and IP. Just a quick reminder that IS is the silhouette obtained from the segmentation model. IP is the silhouette obtained from using the pose estimation model followed by the pose to SIL model. So on the occluded humans 3.6M dataset, we show that POISE performs POISE clearly outperforms both IS and IP, and it's also noteworthy to mention that the difference between POISE's performance and the performance of the fully supervised model is not much. It's nearly a 5.5% difference in terms of MIOU, and with weak supervision, that is under the assumption that some of the images are annotated correctly and despite occlusions, we show that this gap can be bridged. Even on the Unite the People dataset, that is the UPS 31, wherein we evaluate POISE for a number of different types of occlusions. RE stands for random erase, where we put a patch across the image randomly and we crop it off. So under different occlusion severities of random erase occlusions as well as COCO occlusions, POISE outperforms both IS and IP. POISE reasonably outperforms both IS and IP. We now evaluate results for gait recognition with POISE, and wherein we show that on the KCRB dataset, in terms of occlusions on the occluded KCRB dataset, POISE again outperforms IS and IP by substantial margins. In heavily occluded scenarios such as 80%, that means 80% here means 80% of the frames of a particular video of the KCRB dataset are occluded. POISE outperforms IS and IP by substantial margins. On the BRA dataset as well, we see the same trend that POISE outperforms IS and IP by remarkable margins. And so despite with all the differences in the datasets and the conditions, POISE clearly outperforms both IS and IP, thereby providing a very simple self-supervised algorithm that gives us human silhouettes under occlusions. Finally, we look into some qualitative results. Note that all of these images are from the BRA dataset. The BRA dataset images also suffer from atmospheric turbulence and natural occlusions. And especially in third one, if we see that where the legs of the person of this lady walking are covered by ground vegetation, the post key points give us an anatomical information, and using that anatomical information, POISE gives us far more complete human silhouettes as compared to what the DeepLab V3 or the IS or what IS gives us. So this kind of shows that POISE is a much more superior way of estimating human silhouettes under occlusions. In the second image, it is clear that the post to SIL does not hold the body shape at all, whereas the DeepLab V3 output does. So again, POISE, being a self-supervised method, combines the benefits of both and gives very reasonable silhouettes under occlusions. So that would be all from my side. I'm open to questions if you have any.